convection? Fully compressible with high compressibility.
I don't know, it was just one example that I thought might be a good test. I don't know what exactly would happen if the sound speed is less. And
in the linear stability analysis predict the m equal 1 mode?
it's not only m equal 1, it's m equal 1 and 10 times less and m equal 3, so all odd modes.
If you are sufficiently supercritical, I mean. If you are sufficiently supercritical.
Yes.
If you're marginally, it's probably only one, right? One mode.
Yeah, but if you're in a nonlinear regime, you will
Yes.
always be.
Yes, I could.
Yeah,
The linear regime is m equal 1. But the general result,
What?
in image the m equal 1 mode is not stable.
Not always, of course. But very often.
A lot of time
Sure.
you see m equal 1.
That's right. Because for higher M's, of course, you have smaller length scales, which means more diffusion. This, by the way, your work also shows that even though there's nothing in the manual whatsoever, you're actually able to work with that in just 2 weeks and get so many results.
Yeah, I mean, I did not say that it's not good that there's nothing in the manual, but so for the first point to start, I mean, I had your help and the sample setup. That's really.
Yeah, there's, by the way, a
That was
sample
really
setup, which is not Yes, if you look in the samples, Wolfgang, if you look in the samples, there's a thing called cylindrical quad flow, right?
There is two Taylor quad flow. Taylor quad
There's
is
Taylor
quad
quad
flow.
and Taylor quad means
Cyl means cylindrical.
yes.
But it's not part of the order test. I mean, it's part of the order test directory, but it's not being order tested actually.
So it should be there, right?
Yeah, we could do that, yes. Right. And of course, those who actually implemented this were mostly you
Yeah, it was me actually.
and Boris to some extent, or was it mostly you?
Yeah.
Boris, you also did. Who
Both
also
of us
worked
worked
on this cylindrical version, right?
Both of us worked on it, right? And well, like I am seeing that like it is working fine, and well, like I was not trusting it myself actually. Yeah, like
Tested so much yet, you mean?
yeah, true. And
So perhaps you can show me an example where
Sure.
you've seen things going wrong.
yeah, sure. Yeah, like it's in my web.
But he asked whether you see cases where it's going wrong. That's what he
Yeah,
asked,
sure.
right? You have that?
Yeah,
Oh, okay.
if you can open up
Browser maybe,
yeah, exactly.
Are you on the web?
There.
Are you connected?
www.astro.uu.se sorry. Slash building 30. Nordita. I think that it's in Jupyter Seal or something like that. In ABI. Yeah.
Okay, so what is the address?
Nina, maybe I can ask you about boundary conditions. So what are the boundary conditions in radius then? Can you write down?
So in my setup, the MHG setup,
What's wrong
Yes.
here?
So it's
so the usual normal field conditions.
yeah, but in the radial direction. So you have in radius. So you have d by dr of I mean, for example, u phi divided by r is 0, right? That's stress free. You have that, for example, right?
So we're talking about the velocity.
Oh, sorry, that's not what you have, of course. You have actually u phi is.
I have really a given value of u5.
Yes, that's easier given. Right. In an order. And what about magnetic field?
vacuum, the variable component is
which is in J integers.
the derivative and radial direction here, yes, is 0 and both of the components.
Yeah, like it is R
And you have your A.
and 5. Yeah, right.
So that's 0 the way around, I think.
Does that
Yeah,
mean
it's
maybe
zero,
does
right?
it see this?
Yeah.
Probably so, right?
Yeah, because yeah, what should you run actually?
That's vice versa, so we see
As I go.
derivative
Only
here,
R.
0. So I think AR 0 and
So then
here
it would be, okay, then it would be like
Axel.
A, right?
Axel, you see there, you know. Yeah, like it's
that the problem you mean?
Or what is
should,
that?
yeah, exactly.
That's
Yeah,
pi,
it's
right?
That's 5 there.
Pi direction.
R5.
So that's an artificial structure.
Yes. I don't.
And so the
No.
setup is, or what's the difference? It's isothermal or
Yes.
not? It's isothermal.
It looks so weird, this structure.
Let go away
about
it.
But it goes away with time.
How many processes is that?
It was on 4. Yeah.
I was just asking, is it maybe
It's a run with about 64 points in no 128 points in R. In 5 you have more than 400 points or so. So I don't know then, you know, it can be
actually
that
no,
is
it becomes clean again and then it comes again. So maybe you're just too close to the marginal resolution.
could be.
It's always when it's approaching the planet. It seems to be the planet's influence.
Yes.
It seems to be the planet's influence. Doing something.
Oh, that's very nice again.
It could even be the cylindrical gravity of the planet.
Hmm?
Maybe it's the cylindrical gravity that is going. Could that be?
Why is that?
I don't know. Just because that would be the reason why your stuff had this problem. Otherwise, the other stuff works. So that's an idea.
Mm.
So one more. So regarding this, you have the condition on the vector potential, one of the components of the vector potential which involves a derivative, right?
Yes.
Of this form, maybe something like this. So the question was, how do you technically implement this? That was the condition.
So I was simply using the
S&A?
S&A conditions.
Or even, but then that doesn't simulate this, unless it's in S&A. One, if you, so what kind? One way how it appears in the sphere would
Simply
be
without
to do this is equal to minus R minus I, A minus I. Right? To have an anti-symmetry condition on this product. But,
I guess you want symmetry.
that's not even what you're doing then. No, you see, so it's interesting. But even that works. Well, in this case at least.
So, I mean, these boundary conditions are different to what
Yeah.
visibility of
Yeah.
kind of was the first step. And well, I really thought that the center derivative is zero, not correct.
Oh, maybe that's, okay, then that would be okay, of course, yes. Fine.
We
Yes.
don't,
The other,
but don't we have a boundary condition where we can have an arbitrary power of R there?
yes, yes,
I think
that's
that's all you do.
that's right. Including -1, for example, that means that could be this kind of condition.
What about mixed boundary conditions? So if I want to have a perfect conductor, so that would, I think, mean, at least in the magnetic field, that one has d phi over R plus PR d phi is some variable in this case. Here also can pencil here with mixed boundary conditions.
Yes, that by the way, of course, is exactly equivalent to this. This really means the same as saying d by d r of r times b phi.
Yeah.
R. That is the same thing. So if that is 0, then you just require this to be 0. Just like this.
Okay, so
But I'm still not sure whether it's actually, I mean, it's certainly not incorrect, but whether it's, it could still be problematic is one possibility that I'm not worrying about. Because we have this problem in circular geometry, we also find a discrepancy. We haven't been solving that yet.
as I said, it was
Yeah.
the first one.
Yeah,
And
yeah.
I used some of the defaults, simply put in the correct numbers and was looking what's happening. And
It's very good to know that, and in those cases it all works perfectly. That's the way. By the way, the polarization in the x direction is certainly implemented already now, but it's open. It's unclear whether it's correct. I mean, it certainly seems to work correctly, and if it's all periodic. But you can certainly give it a try. Just make to say nx is equal to 2.
okay, so it's that I
It's
simply
already in.
change the file.
It's already
Okay.
in the code.
Did you test when it's down to make sense at all? I mean, compared to the cache efficiency
Oh no,
that is low?
not yet.
Normally the x direction is the most efficient one, much more efficient than the low.
Yeah. No, it will be important, of course, on big machine, on big meshes.
Yeah.
Huge, of course.
Yeah.
Okay. Further questions? Yes.
Regarding the experimentation,
So
isn't
nothing nothing.
also
Anything to? Any further questions regarding Marcus's presentation? Okay, then let's thank Marcus. So yes, Toby.
isn't it then not okay to actually use? Oh no. I was wondering whether it's okay to use early finalize and this MN loop that we have,
Okay.
and calculate pencils extra first so that we have the full pencil in between in the active zone, away from the boundary, where we don't need to do those zones in Y and Z to calculate the resistance.
Early
Because we had this
finalize.
loop
If you
before,
don't know what early finalize actually means, that means that one is making use of the buffer. What is it called? Buffer possibility of MPI. So MPI can in principle start transferring data, which takes maybe then, for example, 10 seconds. And in the meantime, the computer will actually do some calculations. So that's the idea of MPI, of buffered I/O. It's called, right? It's not listening at all. It's called buffered I/O, or not. And the question is whether, and what I know, I think, is that implementations of MPI do not actually support this on Linux clusters at least. And
But I mean, I think that how it's done now is it's not okay in the echo in the code, because you need to call finalize boundaries first before you calculate any pencil, because you need information from the X ghost zones in order to calculate quantities there. In order to calculate a pencil of size nx, you need to have the ghost zone data available, and so you need to finalize your communication before you start calculating anything, any derivative.
yeah, of course, let me just explain what I remember how it's
Why
going.
would we just set X?
So we had
Yeah, right, yeah, okay, yeah, but you
then
need
it can
to,
work for a while.
yeah,
then you
sure.
can make sure that
sure, but that's not done at the
So
moment.
we have a domain which was say from L1 to L2, right? And then we have the ghost zones.
Right.
Okay, that's the first thing. And then in addition, we have the zones which are at a certain distance inside. Like so. And so, obviously, this one we cannot calculate if things are not set, but those ones you can always work on.
Yeah, okay, but then we need to have pencils. Then
That's not practical, right? Because we work with entire NX pencils.
yeah, then we need to have pencils of size -2 then goes.
But that's exactly what we're doing.
No.
Yeah, but it is of course M here.
Yeah, but
Would be
but there's a big advantage,
It's not-
I
why is it
think,
M?
in working with the entire X direction at the same time. Otherwise, we have to change the entire structure of the stroke and make sure,
Oh, I see.
because we're doing everything on these NX pencils, then we have to work with NX 5 6 pencils.
Oh, I see now what you mean. So this is of course installation prior to the X parallelization business. Yes. And now you're saying if you do parallelize in X.
Yeah, then one needs to finalize the X communication first before one actually
Yes.
enters the pencil.
Yes. Yes, that sounds actually right.
And that's not done at the moment.
No, I see. That's likely, yes, that's right. You can do that.
Cheers.
Yes. That was, yeah. Any other comments? What do we have in the post already? Or not? What else do we have on the others? Let's go in more of it.
Yeah, but I mean, what are the items that we
Have on discussion. But if the time is up, we could of course also just finish. One thing we should probably then do is look into this business that we want to go to subversion tonight and try it out. Because that will give all of us the possibility to try and have some feedback to some of us again. And we can possibly do this soon. Otherwise, it will not be so easy, of course. Right, then that's the end of that. The weather is very nice. It would have been nice to do some barbecuing then, of course, but I don't have anything ready. But then what one could, of course, do is one could just go to the IKEA shop and buy some things. If people want to do that. And it will take us half an hour and be back up here in the mountain, for example. We can go to the beach or something, whatever people prefer. But you have to get all the material here. And there's a shop, of course, just on the corner. We could do it also such that those people who do want to do that, they can do that, and others who don't want to do that, they don't have to do it.
We will need to buy barbecues.
It would be one, yes. I think they, yeah. Interested?
I am definitely, yes.
So then, at least two people do it then.
Yeah, I don't think we will do it, we can just play with it.